Now let us see the unit step response of an LTI system. Response means output, unit step means when you give input as a unit step, what will be the output you get for an LTI system, that we are going to discuss. The output y of n of a discrete time LTI system characterized by an impulse response h of n. Let if the impulse response is h of n with input x of n, then you get output y of n has this h of n convoluted with x of n. Let us take this as equation 1. Now step response means input is u of n. When you take input as a step signal, then the response you get is nothing but called step response. So in equation 1, since the response I am taking y of n I am representing as s of n, and here x of n I am representing with u of n. X of n I am representing with u of n. Now this is convolution. S of n is nothing but convolution of h of n convoluted with, so convolution of h of n and u of n. Therefore we'll apply the convolution formula sigma k equal to minus infinity to plus infinity h of k u of n minus k. Therefore here this signal u of n minus k exists only u of n. For k less than n, it is 1. For k greater than n, it is 0. Therefore, our limits, new limits for s of n is sigma k equal to minus infinity to n h of k. So, remember this formula. This we are going to use in the numericals. Similarly, the step response of a continuous LTI system y of t is convoluted. Y of t is equal to h of t convoluted with x of t. X of t is nothing but u of t units. So y of t I am replacing by x of t, h of t into u of t. Now here minus infinity to plus infinity h of tau u of t minus tau. Here u of t minus tau exists for t tau less than or equal to t, it is 1. For tau greater than 1, it is 0. Therefore unit step response of a continuous system is in integral minus infinity to plus t h of tau d tau. Now let us do some problems on it. H of t is equal to u of t. Step response, we know that the step response s of t is given by minus infinity to t h of tau d tau. Therefore integral minus infinity to t u of tau d tau. Why u of tau? Because h of t is given as u of t. Therefore u of tau. You know that u of tau exists from here from minus infinity to t. But u of tau exists only from 0 to infinity. Now the limit will change from 0 to t. So in this range, what is the u of t? 1. Therefore with respect to tau. Therefore tau, one integration is tau between the limit 0 and t. Therefore here s of t step response is t into u of t. Since it is a unit step response, you have to write here whatever the answer you get into u of t. Now let us take h of t as t into u of t. Therefore s of t, we know the formula, minus infinity to t h of tau d tau. Therefore minus infinity to t tau of u of t d tau. Now the limit of because of u of tau will change from 0 to t, and tau is as it is t, and in this range 0 to t the u of t value is 1. So tau into 1 is tau, and integrate this tau with respect to tau, you get tau square by 2. Between the limit 0 and t, you get t square by 2. And the answer is u of t, you have to write if it is step response. S of t is equal to t square by 2 into u of t. Now h of n is equal to u of n. This is a discrete signal. The step response h of n. First whenever you see a problem, you have to just identify whether it is a discrete signal or a discrete signal or a continuous signal. If it is a discrete signal, you apply this formula s of n. If it is a continuous signal, you have to apply this formula s of t. Therefore s of n is equal to sigma k equal to minus infinity to n h of k. Therefore sigma minus infinity to n u of k, because u of h of n I have taken as u of n is given as u of n, u of k. Therefore, but u of k, it exists only from less than 0, it is 1. So less than 0, it is 0. Therefore it is only from 0 to n. Now if you see here from 0 to n, how many ones are there? N plus 1. Suppose you have n equal to 3. For k equal to 0, it is 1. For k equal to 1 also it is 1. For k equal to 2 it is 1. For k equal to 3 it is 1. 1 plus 1 plus 1 plus 1, 4. For k n equal to 3 it is 4. For n equal to 4 it is 5. For n equal to n it is n plus 1. Now let us take h of t as e raised to minus mod t. Here s of t, you know the formula, s of t is equal to minus integral minus infinity to t h of tau d tau. Now we have two cases. Suppose t is less than 0. If t is less than 0, tau is t in place of t you replace with minus t. Minus means mod of minus t is nothing but minus t. Therefore here you get minus of minus t, you get plus e tau. So e tau. Therefore it represent this one e raised to t. Now for t greater than infinity, s of tau is equal to integral. Now it is split it into two, because e of mod of t, for t less than 0 it is minus t, for t greater than 0 it is plus t. Therefore substitute that. Here in place of t we are taking tau, minus infinity to 0 e raised to, here minus is there and minus tau, therefore minus of minus plus tau. For t greater than mod value is here minus symbol is there, plus tau, therefore it is minus tau. Now apply me the limits and substitute here, you get 2 minus e raised to minus t. Therefore step response s of t is equal to e raised to t for t less than 0 and 2 minus e raised to minus 2t for t greater than 0.